If 100 centimeter cube of oxygen pass through a porous plug in 50 seconds, the time taken for the same volume of hydrogen to pass through the same porous plug is dash. Solution. Since this is a question on gas laws that has to do with diffusion of gases, that is gas passing through a porous plug, the law we'll be applying here is Graham's law of diffusion, which states that the rate of diffusion of gas is inversely proportional to the square root of its density, and in some other cases it can be regarded to as the square root of its molecular mass. But in this case here, we will be dealing with the molecular mass of the gases. Then we can say Graham's law of diffusion states that the rate of diffusion of gas is inversely proportional to the square root of its molecular mass. So mathematically, when two gases are involved, we have Graham's law equation. We have the equation of Graham's law to be given as R1 over R2 equals square root of the second gas over square root of M1, where subscript of 1 and 2 refers to the first and the second gas. So here now I will state that gas 1, that is the first gas, is taken to be hydrogen gas. And then the second gas, I can take that to be oxygen. So it can be done vice versa. I can also take my first gas to be oxygen and make the second gas to be hydrogen as well. We'll still be having the same value. So now taking the first gas to be hydrogen and the second gas to be oxygen, then let's proceed. Now the next thing to do here is to write out the values we'll be working with, or let me refer that to as the data we'll be working it in attempting this question. Now before anything, R here means rate, and the formula for calculating rate, that is the rate of diffusion of the gas, is given as volume in centimeter cube divided by time in seconds. So now for R1 now, which is also RH2, that is the rate of diffusion of hydrogen gas. The volume of hydrogen gas is known to be 100 centimeter cube, but the time taken is unknown, because the question says the time taken for the same volume of hydrogen to pass through the same porous plug is dash. So the time taken for hydrogen gas is unknown. That means we can't proceed calculating the rate of diffusion of hydrogen gas. So we have that to be unknown. So now for R2, that is the rate of diffusion of the second gas, which is oxygen gas. Going back to the formula, which is volume over time, we have the volume of oxygen gas to be 100 centimeter cube divided by the time taken, which is 50 seconds. So this gives us 2 centimeter cube per second. That's the rate of diffusion of oxygen gas. So now we've gotten the rate of diffusion of the gases. Now the next thing to do now is to determine the molecular mass of each of the gases. So first, the first gas now, M1, which is same thing as MH2. The molecular mass of hydrogen gas, which you can also refer to as the molar mass of hydrogen gas, that's H2. So we have 2 atoms of hydrogen present, so that gives us 2 times 1. 1 here is the atomic mass of hydrogen, so which is equivalent to 2. So we have the molecular mass of hydrogen gas to be 2 grams per mole. And for the second gas, M2 now, which is same thing as MO2, that is the molecular mass of oxygen gas. So for oxygen as well, we have 2 atoms present, so that's 2 times the atomic mass of oxygen, which is 16. So this gives us 32. So we have 32 grams per mole. Now R1 remains unknown. We've gotten R2, we've gotten M1, and we've gotten M2. So the next thing to do now is to calculate R1 using the equation above. So let's substitute the values we've gotten into the equation above, or better still, say the formula we'll be using in calculating. So now based on the formula here now, R1 now, I can rewrite the formula. Since I'm taking the subscript of 1 and 2 to be hydrogen and oxygen gas respectively, then the equation can be written as R subscript of hydrogen gas, that is the first gas, divided by that of the second gas, oxygen, to be equal to the square root of the second gas, that is square root of the molecular mass of the second gas, that's MO2, divided by the square root of the molecular mass of the first gas, that's MH2. So now let's proceed to substitute the values we've gotten. So here now, RH2 remains unknown, divided by RO2, which is 2 cm³ per second. So we can neglect the unit so as to make the calculation faster, so as to avoid any form of confusion while calculating. So we have 2 equal to the square root of the molecular mass of oxygen gas, which is 32, divided by square root of the molecular mass of hydrogen gas, which is 2. This is 2. Here I have RH2 over 2 to be equal to square root of 32. Now I have that to be 4 root 2 divided by root 2. So here now I have RH2 over 2 to be equal to 4 over 1. Hence I can say RH2 cross multiplying equals 4 times 2 over 1, which is 8. Then the unit cm³ per second. Now we've gotten the rate of diffusion of hydrogen gas. And that doesn't mean we've come to the end of the question yet, because the question says we should calculate the time taken for hydrogen gas to diffuse. So now going back to the formula for rate in cm³ per second equals volume in cm³ divided by time in seconds. Since we've gotten the rate of hydrogen gas and we are given the volume of hydrogen gas, it says same volume as that of oxygen, which is 100 cm³. Let's calculate the time, so that means time here is unknown. So to get time, we'll be making time the subject here. So here time in seconds equals volume in cm³ divided by rate, cm³ per second. So now time of hydrogen gas will then be volume of hydrogen gas, which is 100 cm³ divided by the rate we've gotten, that's 8 cm³ per second. So this gives us 12.5 seconds. So now with the calculation we just did, now we can see that the time taken for the same volume of hydrogen to pass through the same porous plug is 12.5 seconds, and that will be the final answer. Kindly do well to subscribe to this channel and also click on the notification bell so as to get notified as soon as new videos have been posted. Thank you.